Assalamu alaikum guys, welcome back. Okay, so let's begin with the reactions of period 3. Let's continue with the reactions of period 3. We completed till the reaction of elements with oxides. We did that in the previous lecture, right? In lecture 38. Now we are going to do the reaction of period 3, oxides with water. Okay, reactions with oxygen has been completed, elements with oxygen, and now we are going to do oxides with water. So let's get started. Right guys, so basically the sodium oxide, which is an oxide of course the group 3 metal, period 3 metal, sodium. Now this sodium, when it reacts with oxygen, will produce sodium oxide, which is a basic oxide, and it is soluble in water. When it dissolves in water, will produce sodium hydroxide, which is a strong alkali. Strong alkali means anything that fully dissociates in aqueous solution to produce OH negative ions, and its pH is gonna be very high, close to 14. It's 13 to 14 approximately. Okay, and this equation is important, the pH is important, and that's it. And the balancing, of course, is important. You must know that it is soluble in water. Let me just write it down here. Soluble in water. And it's a clear solution that you will get. Then coming to magnesium oxide. Magnesium oxide, we've talked about magnesium oxide previously slightly, but over here we are going to talk about it in a bit more detail. It is a white solid. Remember, when magnesium reacted with oxygen, it produced magnesium oxide, and by heating, a brilliant white flame was produced. Now this magnesium oxide is a solid, and it is not very soluble in cold water, by the way. Okay? When it dissolves in water, it produces magnesium hydroxide, and this is quite a slow reaction. Okay, and the magnesium hydroxide which is produced is also not very soluble in water. So both of them are partially soluble in water, therefore you get a cloudy solution. Okay, this cloudy solution is obtained. Why is it? Okay, this was a question on the past exams, that when magnesium oxide dissolves in water, it produces a cloudy solution. Why does the solution turn cloudy? The answer to that was because magnesium hydroxide which is produced is also partially soluble in water. So a precipitate is actually produced, okay? It is partially soluble in water. Since it is partially soluble in water and not fully soluble in water, it is a weaker alkali as compared to sodium hydroxide. Because remember guys, what are alkalis? Alkalis are actually soluble bases. And alkalis are substances that dissolve in water to produce OH negative ions. So now, if the alkali dissolves more, it will produce more OH negative ions, and so the pH is gonna be greater and it's gonna be a stronger alkali. But if it dissolves less, it will dissociate less, it will produce lesser OH negative ions, and as compared to the previous one, it's gonna be a weaker alkali. pH is approximately 9 to 10. If you are asked on the exams, well, this has been asked on the past papers as well. So the answer in that marking scheme was 10, but they do accept 9s as well. Okay, so the pH of this solution which is made is approximately 9. See, it's a weaker alkali because its pH is not very high. It's lesser than the pH of sodium hydroxide. Partially soluble and cloudy solution is made. And these are the two basic oxides that you have. Okay, and this completes their reaction. Now coming to the third one, Al2O3, aluminum oxide, which is an amphoteric oxide. And this amphoteric oxide is actually insoluble in water. Okay. Similarly, SiO2 is also insoluble in water. What does amphoteric actually mean? I didn't tell you what amphoteric was. Amphoteric oxide, you guys already know this from your O levels, by the way. Amphoteric oxide is basically an oxide that can react with both. By both, I mean both acids as well as bases. Okay? This is the characteristic of amphoteric oxide. Any oxide that reacts with both acids and bases to produce salts are amphoteric oxide, and Al2O3 is the classical example of an amphoteric oxide. Okay, and we'll of course be doing these reactions when we'll be doing reactions with acids and bases later on in the upcoming lectures. SiO2 is an acidic oxide. It is insoluble in water as well. Okay, then P4O10, phosphorus 5 oxide. Phosphorus 5 oxide, it is an acidic oxide. Now, following SiO2, all the oxides over here from silicon to chlorine are acidic. Okay, they are all acidic oxides. SiO2 is acidic, but it does not dissolve in water. Okay, it is acidic because it can react with basic oxides. Okay, doesn't react with acidic oxides. P4O10, meaning phosphorus 5 oxide, dissolves in water to produce phosphoric acid. Okay, this is called phosphoric acid, H3PO4. H3PO4 is the formula of phosphoric acid, and the pH is approximately 2. It is a strong acid. What is the definition of a strong acid, by the way? Strong acid is an acid, any substance that fully dissociates in aqueous solution to donate protons or to produce H positive ions. Okay, any of these two can be written down. So what is a strong acid? Strong acid means, strong means fully dissociable, fully dissociable. Okay, so any acid that can fully dissociate in aqueous solution is a strong acid. Any acid that partially dissociates is a weaker acid. Okay, it's a weak acid actually. Then P4O6, phosphorus 3 oxide. Okay, this was phosphorus 5 oxide, this is phosphorus 3 oxide. The oxidation state of phosphorus is 3 over here. When it dissolves in water, it produces phosphorus acid. This is called phosphorus acid. Phosphorus acid. Okay, and this acid H3PO4, the more oxidized acid, is called phosphoric acid. Phosphoric acid. Okay, just the last two terms are different. Okay, this is us and that's ick. Okay, phosphorus, H3PO3, and H3PO4 is phosphoric acid. Okay, the more oxidized one is phosphoric, the less oxidized one is the phosphorus acid. pH is approximately 2. Both of them are strong acids. Then coming to sulfur dioxide and sulfur trioxide, both are acidic oxides. They dissolve in water to give, like phosphoric and phosphorus acids, the sulfur dioxide dissolves in water to give sulfurous acid, and sulfur trioxide dissolves in water to give sulfuric acid. Okay, again sulfurous and sulfuric. H2SO3 is sulfurous and H2SO4 is sulfuric. H2SO3 is formed by SO2, sulfur dioxide, and H2SO4 is formed by sulfur trioxide, SO3. The sulfurous acid which is produced, it can be further oxidized to sulfuric acid as well. Okay, and this is quite a common reaction that occurs in the atmosphere. The sulfurous acid which is produced when sulfur dioxide dissolves in rainwater, because I told you in the previous lecture the sulfur dioxide is continuously being emitted out by the factories which burn fossil fuels like coal, which contains sulfur. Now the sulfur dioxide which is emitted out by those factories, when it dissolves in the water, in the cloud water, in the rainwater, it produces sulfurous acid, and this sulfurous acid in presence of atmospheric oxygen can be oxidized to sulfuric acid, whereas this sulfur trioxide this sulfur dioxide can also oxidize to sulfur trioxide. Okay, and this sulfur trioxide can then directly dissolve in water and produce H2SO4 in the atmosphere, by the way, not in the lab conditions, not under lab conditions. If sulfur trioxide dissolves in water in the lab, then you know what will happen? The person will not be left. Okay, the person will not be alive to tell the story then. Okay, basically an explosive reaction will occur in the laboratory, and a thick mist of H2SO4 will form, and that H2SO4 will remain in the atmosphere, and the person will die of suffocation and other diseases. Okay, other problems basically. So sulfur trioxide is never allowed to be dissolved directly into water. Even in the contact process, the sulfur trioxide is not dissolved in water. It is dissolved in sulfuric acid so that the reaction could be less exothermic, okay, and less vigorous, and then it is diluted further to the desired concentration, but not directly into water. Okay, because this is a very exothermic reaction. Let me just mention that down. If you do this, you won't be left to tell the story then. Okay, exothermic reaction. Then coming to Cl2O, this is called chloric 1 oxide. Okay, why chloric 1 oxide? Because the oxidation state of chlorine over here is +1, and you can calculate that. Okay, 2x plus minus 2 equals 0. So x is equals to plus 1. Okay, minus 2 will go there, become plus 2 divided by 2 will give you plus 1. So it's, the oxidation state of chlorine here is plus 1. When it dissolves in water, okay, let me just write it down over here. This is plus 1. When it dissolves in water, it produces HOCl. HOCl is known as hypochlorous acid. What is it called? It's called hypochlorous acid. Chlorous acid. Okay, and what's the significance of hypochlorous acid? This hypochlorous acid is actually the acid which is used as a disinfectant in swimming pools. Disinfectant. Okay, the chlorination basically is done by HOCl, this compound of chlorine. Okay, chlorine or is added to drinking water as a disinfectant as well, right, to kill the germs, etc. It's the HOCl that is added. Okay, that's a derivative of chlorine, of course, and it is added to water, to the swimming pool water, to the drinking water, which kills all the germs in there. Okay, it is a disinfectant, and this HOCl, by the way, in presence of sunlight, can further be broken down, broken down into HCl along with oxygen. Yep, along with oxygen. Okay, so the HOCl can further be broken down into oxygen. And yeah, that's it. After this comes, that's a disinfectant, and please do learn that. Okay, HOCl is a disinfectant. These are all the reactions that you are expected to learn, by the way. Okay, do not forget what is formed when sulfur trioxide dissolves in water. What is formed when phosphorous acid is formed? What forms the phosphorous acid? What forms the sodium hydroxide? Why is a cloudy solution made when magnesium oxide dissolves in water? You need to know all of these. Okay, do not forget any of these. This actually completes the reaction of oxides with water. Okay, and let's just do a quick recap of what we've done so far. Sodium oxide and magnesium oxide, these are basic oxides. When they dissolve in water,